Today we're going to be using a very commonly used but commonly misunderstood component, a transistor. Transistor is a switch. Similar to the digital pins in the Arduino, they turn things on and off. Now, why do we need a separate component if we already have 14 digital pins? And the answer is very simple: power. The Arduino digital pins put out very, very small amounts of power, in the order of 20 to 30 milliamps. That's enough to power a few LEDs, maybe a little buzzer or a little speaker. But we often want to power bigger things, things that move, things that heat up, things that cool down, things that make a lot of noise or a lot of lights. And in all those cases, we're going to use a transistor. Now, the number one misconception about transistors is that they power larger devices. Transistors don't power larger devices, they're just switches. They turn the circuits on and off. If I were to turn on and off the light switch in a house, you wouldn't think that I was the one powering the lights. The switch is what's allowing electricity to come from a larger power source into your larger device. Now let's take a look at the circuit. Here is our transistor circuit. We have a battery pack that we're going to be using to control a fan running through the screen wire into our transistor switch and back to ground. On the right side here, we just have an Arduino running a blink code with a random delay to turn the fan on and off. Now our circuit's complete, but the fan isn't on because our switch is not activated. So we're going to take our data pin from our transistor and plug it into pin 13 from our Arduino, but the fan is still not on. The reason is, if you remember from very beginning our lesson on electricity, is that electricity only flows if there's a full circuit. Now right now the electrons are trying to flow from the Arduino into the transistor to turn it on. But there's no way for the electrons to get back to the Arduino. So they're not willing to go out into the transistor. And this is the second most important thing to remember by transistors, is that all the grounds in your transistor circuit have to be connected. In this case, we have two grounds. We have one ground inside the Arduino coming from this AC barrel jack. We also have a ground internal to this battery pack. It has a plus and a minus side. So we're going to use this black wire over here. It's connected to our Arduino ground, and we're going to connect it to our battery pack ground. So now all the grounds of the circuit are connected, and our fan is turning on and off from our Arduino in the same pattern as the blink. Now, transistors come in a lot of different shapes and sizes, as well as names. We use them in the stepper motor lab. A stepper motor driver is really just a series of transistors turning on and off a motor. Also in year 2 in our car lab, when we use the H-bridge motor driver, it's just a series of transistors turning on the car motors. Let's try and build the transistor circuit now. Remember, if it moves or heats up or cools down or gives off a lot of light or a lot of noise, it's probably going to need a transistor and a separate power supply. These will make your projects run so much smoother. There is one more thing I want to mention. There is something called a relay for things that are really big or for things that actually need to plug into the wall. They look like this. Sometimes they're nice looking on the outside, sometimes they're not. They have wires that plug into the Arduino to turn on and off the switches. Hopefully, if we have the right power with the right switch, all of our components are going to run really smooth. Good luck.